All right, let's get right into it. We're going to be detectives today, looking into a cosmic cold case, a huge planetary-scale mystery. And the victim? Well, it's the entire atmosphere of Mars.
You know, for years, scientists have been staring at Mars and asking this one big question. We see all this evidence, dry riverbeds, old lake basins, so where did all the water go? But see, to answer that, you have to ask an even more fundamental question. What happened to the air that kept all that water on the surface in the first place?
And just like any good detective story, there are clues. And those clues are all starting to point to one prime suspect. Scientists have been piecing this together for a long time, and they're pretty sure they know who, or, well, what, has been stealing Mars's atmosphere for billions of years.
And the culprit is the solar wind. Yep, that constant, relentless stream of particles blasting out from our own sun. Now, here on Earth, we're lucky. We've got this awesome global magnetic field. Think of it like a giant invisible force field that protects us. But Mars, well, its shield went down. Billions of years ago, its core cooled off, the magnetic field just vanished. And that left its atmosphere totally exposed, getting sandblasted away, little by little, for ages. So to finally nail this suspect and get the smoking gun, NASA's sending a pair of dedicated detectives all the way to Mars. Their mission? To catch this atmospheric thief red-handed.
All right, so let's set the scene of the crime. Before we introduce our detectives, you really need to grasp the sheer scale of this heist. We're talking about a planet that used to look a whole lot more like our own.
Just look at this transformation. On one hand, you have ancient Mars, warm, wet, with a nice, thick atmosphere. And then you have Mars today, a cold, barren desert with an atmosphere so thin it's barely there, like 1% of Earth's. The big question, the whole point of this investigation, is figuring out how it went from point A to point B.
Okay, time to meet our investigators. The mission is called ESCAPADE, and it's taking a totally new angle on how to study this whole atmospheric escape thing.
Yeah, I know. It's a bit of a mouthful. ESCAPADE stands for Escape and Plasma Acceleration and Dynamics Explorers. But honestly, the name tells you exactly what it's doing. It's all about watching how plasma, you know, the super hot stuff the solar wind is made of, slams into Mars and literally kicks atmospheric particles right off the planet and into space.
And here they are, our dynamic duo, Spacecraft Blue and Spacecraft Gold. They're identical twins, built by Rocket Lab, and the fact that there are two of them working as a team, well, that's the secret sauce. That's what makes this whole mission tick.
So, how is this mission gonna crack the case? I mean, we've sent probes to Mars's atmosphere before, right? But ESCAPADE, it has a secret weapon, something no other mission has ever had.
So what's the big deal? Why two spacecraft instead of one? Why is this whole twin orbiter thing such a game changer for figuring out what's happening in Mars's magnetic environment?
This really lays it out. Think about past missions, even incredible ones like MAVEN. A single orbiter is like taking a photograph. It gives you a perfect snapshot of what's happening at one specific point in time and space. But with ESCAPADE's twins, you're not taking a photo anymore. You're shooting a 3D movie. You can see what's happening here and what's happening over there at the exact same time.
And this quote from the science team just nails it. Think about it. If you're one person and you see something change, you don't know, did the thing itself change, or did you just move to a different spot? With two spacecraft, you eliminate that guesswork. You can finally tell if a change is happening over time or across space. It's a huge deal.
Right, so we've got our detectives, we've got their strategy. Now let's talk about the nitty-gritty. How are they going to get to Mars, and what's in their toolkit when they arrive?
So, the plan is to launch from Cape Canaveral in the fall of 2025. And get this, they're hitching a ride on a brand new rocket, Blue Origin's New Glenn. So this isn't just a big mission for Mars science, it's also a huge high-profile flight for a new heavy-lift launch vehicle.
And it's quite a road trip. After they launch, they've got about an 11-month journey just cruising through space to get to Mars. They'll show up sometime in 2026, but it's not over then. It'll take a few more months to carefully get into their perfect science orbits before the real detective work, the main coordinated science phase, can even begin.
So what's in their detective kit? Each spacecraft has 3 identical tools. First up is EMAG, a magnetometer. Think of this as scanning the crime scene, mapping out the magnetic fields. Then there's EESA, which is basically a particle counter. It's watching the bullets coming in from the solar wind and also counting the atmospheric escapees trying to get away. And finally, you've got ELP, a probe that measures the plasma all around them. You put the data from all three together, and you can follow the entire chain of evidence. You can see exactly how the solar wind pulls off the heist.
Okay, so let's zoom out. What's the big picture here? Why does solving this one very old mystery on a faraway planet actually matter? Well, it turns out it's about a lot more than just Mars.
For starters, it's about that huge question. Are we alone? If we can figure out exactly how Mars lost its atmosphere, we can finally piece together its entire climate history. We can understand why the water disappeared, and that gives us our best shot at figuring out if it ever could have supported life.
And then there's the cost. This mission is proof of a smarter, more nimble way to do planetary science. ESCAPADE is one of these smaller, faster, cheaper missions. It shows that you don't always need a giant, multi-billion-dollar probe to answer the big questions. It's opening the door for a whole new way to explore our solar system. And finally, it's about rockets. By flying on a new commercial rocket like New Glenn, it helps build confidence and creates more options for getting science out into the solar system. You know, more competition, more rockets, that ultimately just means more science can get done. It's a win-win. Look, if there's one thing to remember from all this, it's this. We're going from taking still photos of this process to watching a full-blown movie of Mars's atmosphere literally bleeding out into space. That is a huge leap forward. It's a whole new way of seeing.
And that brings us to the final most important point. This whole investigation, it's not just a history lesson about another planet. It teaches us the fundamental physics of how planets hold on to or lose their atmospheres.
Because when we understand exactly how Mars lost its protective shield, we learn so much more about the one that keeps us alive right here on Earth. You know, figuring out how a world dies is maybe the best way to really truly appreciate what it takes to protect our own.